Hey, what's up, everybody? We're going to cover the first 4 sections of Chapter 3 today, expansion and some of the basics of factorization. We'll do more challenging factorization in the next video. This is a super important topic, and it is one that we will continue to see throughout the course. And not only that, we will continue to see it in more and more complicated and abstract scenarios. It's okay if you don't master it right away, but you need to be comfortable with this topic as we move forward. Because if you don't get factoring now, then you are going to struggle a lot when we get further along. And I'm just telling you this from experience. So make sure that you feel good about this topic sooner rather than later. Okay, with that warning out of the way, let's begin. Like I said, some of this you better know already. I think you've seen the distributive property. I really hope I don't need to explain it. Anything that's outside of a parentheses, we multiply it by everything that's inside of the parentheses. Great. There's 2 examples at the bottom of the screen. Pause it if you need to read them. Let's move on to something more challenging. Okay, these at least have a little more going on. So in the first one, we're going to distribute the 3 to both of these and the 2 to both of those. We see that happening in this line. I would never write that line down. I would just skip immediately down to there. So we got 3x plus 15 plus 8 minus 2x. Combine the like terms. Final answer. Same thing in the next one. We're going to distribute the y, and we're going to distribute the negative 3y. That's one thing we should be careful about. So y times 3y, that's 3y squared. Y times negative 1 is negative y. Negative 3y times 2y is negative 6y squared. And negative 3y times negative 5 is plus 15y. Again, combine like terms, and there's our final answer. So we see this as building upon a previous topic with exponents, because when we multiply, for example, in that last one, when we multiplied y times 3y, we know that we need to add the exponents. That's y to the first times y to the first, which gives us a y squared. We can have more than just a single number outside of the parentheses. So here we have a binomial, fancy word, multiplied by a binomial. So it's two expressions, both with addition or subtraction in them. Just like before, everything outside of one parenthesis is going to get multiplied by everything in it. In other words, we're going to take the A and multiply it by the C and by the D. And then we'll take the B and multiply it by the C and by the D as well. So we have 2 numbers on the left, 2 numbers on the right. 2 times 2 is 4. And look at that, we have 4 products when we're done. So that's a way to check to make sure that you haven't missed anything. So down below we have 2 examples. In the first one we have x times x, which is x squared, x times negative 3, which is negative 3x, 4 times x, which is 4x, and 4 times negative 3, which is negative 12. Combine like terms, and that's our answer, x squared plus x minus 12. Same thing in the one below. I have nothing else to add to it. Pause if you'd like to read it and think about it for a moment. Okay, this is called the difference of 2 squares. It's called that because on the right-hand side we have a squared minus b squared. So that's 2 numbers that are being squared, and we're taking their difference. This is really important, as we'll see when we do this process backwards. When we hit factorization, this is a huge shortcut, huge time saver. For multiplication, it's not as important, but we can use it to save ourselves some writing. Or I guess we could do these mentally too. So let's take a look at this. So we've got x plus 4 times x minus 4. Because I see this structure of 2 things being added together and then the exact same 2 things, but there's a minus in between them, I can use this shortcut to come up with the answer. The answer is going to be the very first thing squared minus the second thing squared, and 4 squared is, of course, 16. So I don't need to go through the process of doing x times x and x times negative 4 and 4 times x and 4 times negative 4. I could do that, and I would get to the same answer, but that would take me a lot longer, and I might have to write down a whole bunch of extra steps, and I want to be as efficient as possible in my work. So this is a nice shortcut for us to know. Over on the right, we have another example. 3x squared is 9x squared, because I'm squaring the 3 to get 9, and I'm squaring the x to get x squared. And then we have minus 2 squared, which is 4. So there we go. But again, this only works if we see the exact same two numbers in the exact same order, but in one of the brackets it's plus, and in the other brackets it's minus. So that's a difference of 2 squares. We have another shortcut, and it's called perfect squares expansion. And this is called a perfect square expansion because on the left we have some expression which is being squared. So a plus b squared. If you wanted to do this the long way, you would have to write out a plus b times a plus b. That's the same thing as squaring a plus b. If we did that, let's actually do this one the long way. We would do a times a, which is a squared. And then we do a times b, which is ab. And then we do b times a, which is ba, but I can write that as ab, right? Because the order for multiplication doesn't matter. And then I would do b times b, which is b squared. And then look, those two are like terms. There's two ab's. And so you see we get the exact same thing as we have on the right-hand side up top. So we can use this as a shortcut. If we can just think about what the a is and what the b is, we can write our answer in this form. Let's check out down below. In our first one, we have 2x is our a value, and 1 is our b value. So my final answer, and again, I don't need to write out all this work. My final answer is going to be 2x squared. So that's 4x squared, plus 2 times 2x times 1. That's my 2ab. And 2 times 2x times 1 is just 4x, plus 1 squared, which is 1. Let's talk out the one on the right. And then if we square 3, we get 9. And then if we do 2 times 3 times negative 4y, that's going to give us negative 24y. And then if I square negative 4y, I'll get 16y squared. So again, you could do this a long way, and perhaps at first you'll feel more comfortable doing that, but I'm looking for people to be efficient and to work fast. So this shortcut is really, really helpful. A little more expansion. We're in section B now. So now it's not two binomials. Now it's actually a binomial times a trinomial, but it's really the same thing. So we're taking the x is going to multiply by all 3 terms in the second expansion, and then the 3 gets multiplied by all 3 terms in the second expansion. Notice, like I said before, we got 2 terms here, we got 3 terms here. 2 times 3 is 6. How many terms do I have in my answer? 6. And then we combine the like terms afterwards. But it's always good to check yourself after you've done a big multiplication like this. Make sure that you didn't miss any. Make sure that you didn't do any extra. And if you do it in an orderly fashion, you should be fine. So I would always start with the first value and then go 1, 2, 3, and then the second value and go 1, 2, 3. Of course, you could go in the opposite direction. You could always start with the x squared and go 1, 2, and then do the 2x, 1, 2, and then take the 4, 1, 2. You get the same 6 numbers either way. We could also have more than 2 expressions being multiplied together at the same time. This is fine. Think about when you multiply 3 numbers together. If I asked you to multiply 3 times 4 times 5, you don't multiply them all together at once, right? You would choose 2 of them, multiply them together, get an answer, and then you'd multiply the third number by that answer. It is the exact same process here with variables. So here we've taken the first 2, we're multiplying them together to get this answer using the techniques we just saw, and then we multiply, well, then they combine like terms, I guess, to get there, and then we multiply all 3 of those in that first parentheses by the x plus 2 in the second. So we have 6 terms here, and we combine like terms, and we get a final answer. We didn't have to choose x plus 1 and x minus 3 in the very beginning. We could have actually started with x plus 1 and x plus 2. Or we could have started with x plus 2 and x minus 3. I promise you, you'll get the exact same answer no matter which two you start with. So the choice is really up to you. So hopefully so far so good. Most students I've had in this course are usually pretty comfortable with expansion. But the next section is where things can get a little more challenging, and this is when we reverse the whole process and we factor, or the British would say factorize. So this is when we take something that is in the form of a sum or difference of multiple pieces, so what we have over here on the right, and we change it to two or more factors over on the left. Now first, let's just look a little bit at common factors. So in American schools, we generally call this the greatest common factor, or the GCF. Our book is calling it the highest common factor, or the HCF, but it means the same thing. So basically, when I look at 6x squared plus 4x, both of those terms have something in common. Now you could figure out what that something is by factoring the entire thing as they've done here. So 6 is 2 times 3, and x squared is x times x. And then 4x is 2 times 2 times x. And then seeing, hey, what do they both have? Well, they both have a 2, and they both have an x. So let's take those out. If I take a 2x out from both of them, then what's left behind is going to be a 3x, oops, that one, for the first term, and then just a 2 for the second one, with a plus sign in between them. I don't really think it's necessary to write all that out. I wouldn't have written any of that step. I think we can just look at this expression and realize, hey, you know, 6 and 4, they're both divisible by 2. And x squared and x, clearly they both have an x there. The example over to the right is pretty similar. We just have both numbers are negative, so we can pull a negative out for our common factor. This can also be a little more complicated. Down below, our common factor is actually a binomial itself. So we've got negative 4 times a plus 1 plus a plus 2 times a plus 1. Do you see how they both have an a plus 1? So if we recognize that, we can pull the a plus 1 out here. And what's left from the first term is just the negative 4 plus what's left from the second term is just the a plus 2. And then we combine like terms. And yeah, there's another way to do this. You could have expanded the whole thing. So multiply the negative 4 by the a plus 1, and then multiply the a plus 2 by the a plus 1, and you'll get this expression in black over on the right. And then you could combine your like terms there, and you'll have a squared minus 2a minus 2. But we haven't talked about how to factor that. Now maybe you already know how to factor that. That's great. But I think it's actually much slower to do it that way anyhow than to just recognize from the very beginning that they both had an a plus 1 as a common factor. All right, difference of two squares. It's back, and this is where it comes in super handy, because if you have an expression like either one of these two, it can be really hard to guess and check your way to figuring out what their factors are. It's really good if you've got a system. So let's look at this first one. Do you recognize that 4 is something squared? 2, right? Do you recognize that 9y squared is also something squared? 3y squared, right? That's what we've got written down on that line. That means we have a difference of two squares. We have a squared minus b squared, where in this case a is 2 and b is 3y, which means that we can factor it into a plus b times a minus b, or 2 plus 3y, 2 minus 3y. All we're doing is taking square roots in our head and writing it in the form that we're given from the difference of two squares. This one on the right, we've got 9a. Now 9 is a perfect square, but 9a isn't, because then we'd have the square root of a, and that's not very nice and neat. And also we have 16 which is a perfect square, but a cubed isn't. What are we going to do? Take the square root of a cubed? That sounds yucky. But instead, what we should do, and this should actually be our first step every single time, is we can notice that there is a common factor. Both 9a and 16a cubed, they both have an a in them. So as a first step here, we can factor out that a, leaving behind a 9 minus 16a squared. And both of those are perfect squares. 9 is 3 squared, and 16a squared is the same as 4a all squared. And so now we have a difference of 2 squares. So we use the a plus b, a minus b form. And our final answer is a, that common factor that we pulled out, multiplied by 3 plus 4a, multiplied by 3 minus 4a. Just like the difference of 2 squares we had with expansion and factoring, we also have the perfect squares factorization in both expansion and factoring. Okay, so we also had perfect squares with expansion, and we have that with factoring as well. This one's a little more complicated looking, so we're going to be on the lookout for anything that's in either of those two forms, where we have something squared plus 2 times that something times another something plus that other something squared. Oh boy. Let's take a look at an example down here. We've got 4x squared plus 4x plus 1. Okay. Is 1 a perfect square? That one's easy. Yes. 1 is 1 squared. So we can set b equal to 1. Is 4x squared something squared? Yes. That's 2x all squared. So we can set a equal to 2x. And we check that middle term, 4x, is that equal to 2 multiplied by 2x multiplied by 1? Yes, it is. That means that we have an expression here in that form, which means we can factor it into that form. Our final answer is just going to be a plus b all squared. That's 2x plus 1 all squared. On the right, this is another one where we're going to have a common factor first, because 18 is not a perfect square, 8x squared is not a perfect square, but all three of these numbers, 8, 24, 16, 18, they're all divisible by 2, so we take out a common factor. So we got a 2 out. And I know the 2 is going to be part of my final answer. What's left inside? 4x squared minus 12x plus 9. Is 9 a perfect square? Yes, it's 3 squared. Is 4x squared a perfect squared? We just agreed that it was. Yeah, so that's 2x squared. We've got a minus here, so just be careful of that. That means we're going to have a minus in the final answer. We've got a, which is 2x, minus b, which is 3 squared. Dunzo. That might have seemed like a lot for you right there, and if that's the case, then you really want to make sure that you meet with me or another teacher, parent, older sibling, friend, whatever, someone who can help you out with it over the next week or so, because like I said, this is a super duper important topic, and not to scare you or anything, but you will not succeed in this course if you aren't comfortable with expansion and factoring. There's just no way around it. I'm sorry. Now I'm going to extend this into show you one more technique for factoring. I truthfully don't use this technique that's coming up. I use a technique that I will show you in the next video, but every once in a while you find someone who likes this technique. And I'm including it here rather than the next one because I wanted to give you just some more time to think about it and let it sink in. I'll do some examples in the next video where I'll compare methods, so we'll see it again. So this is called factoring by grouping, that's what I like to call it. So it's when we've got 4 expressions added or subtracted together, and we pair them off so that each pair has something in common. So in this example up top, right, our first pair, AB plus AC, they've both got an A in common, and our second pair, BD plus CD, they've both got a D in common. And so we take out a common factor from each of them. We get here, and then what do we notice? Oh, wait. When we took the A out from the first 2 terms, what's left over was a B plus C. And when I take out the D from the next 2, what's left over is also a B plus C. That means that a B plus C is the common factor for each of those two terms, so we can take that out and we get b plus c multiplied by a plus d. So let's look at this down below. We've got 3ab plus d plus 3ad plus b. There's no common factor between all four of them. So we're going to pair them off. Now notice that we can rearrange the terms, right? So let's switch places for the d and the b. Now the first two terms both have a b in them. So we can factor that out, leaving behind a 3a plus 1. The next two terms both have a d in them. So we can factor that out, leaving behind a 3a plus 1. Ah, both of them have a 3a plus 1. So we can factor that out, leaving behind a b plus d. And that's a final answer. There's actually another way we could have done this if we'd organized the terms in a different order. As you see over here at the right in blue, we could factor out a 3a from those first two terms, leaving behind a b plus d. But then the other two terms have nothing in common, but guess what? They're b plus d. So now we have this term with a b plus d and this term with a b plus d. So again, we take out the b plus d. What's left from the first part is the 3a. What's left from the second part? Well, we factored out the entire thing. So when we do that, we leave a 1 behind. And of course, it's the exact same answer as what we had over here. Here are two more examples of it, and the only thing I'll say about them is that in both cases, if you switch these two terms and tried factoring by grouping the other way, you'd get the exact same answer. So actually, that's what I would recommend that you do right now to make sure you understand this. So rewrite each of these problems, switching the two middle terms, and you should get the exact same answers at the end. So that's it for this topic. We covered expansion, which shouldn't be too bad, and some basics of factoring, but that's just going to get worse in the next video. So please, like I said already, make sure to speak to me or someone else who can help you with this if you need it. Make sure that you stay on top of this topic because we don't want anything to snowball out of control.